Hello everyone again to my YouTube channel. Today I will discuss with you one of pillar of data science, one important topic. That's what's called linear programming. Well, let me firstly give you a definition of programming and why it's coming. So, linear programming are the problem of maximization or minimization a linear function that is subjected to a linear constraint. As means linear programming is coming to solving the problems of maximizing or minimizing a linear function. Okay, I will show you examples and I hope be clear for you. So the constraints may be equals or inequalities. The constraint may be equalities or inequalities. That means to minimizing or maximizing a linear function. First, we have some constraint. Cannot ignore or cancel those constraints. So the optimization problems involve the calculation of profit and loss. Well, linear programming problems are an important class of optimization problems that helps to find the feasible region and optimize the solutions in order to have the highest or lowest value of the functions. Here, what we do based on some methods, we need to find the highest or lowest function. That's depend of the problem we face. Well, here I will show you the component or the basic component of linear programming. So the basic component of LP or linear programming are as follow. We have firstly decision variables. Of course, when we try to write in our linear functions, we should have some decision variables because based on decision variables, we can maximize or minimize our function. The second component is the constraint. The constraint, as I said before, we cannot cancel constraints in area of business. For example, in many manufacturing, we cannot produce all the time the products. We have some constraints of machines, for example, of hours of all the time we need to produce these products. We have some limitation. Okay, well, we have also the data, the numbers as consider it for to replace the data or the numbers we need to replace it in this constraint and this uh, decision variables. And the last component is objective functions. Objective functions that mean what is the combination between or what is the linear combination we have between the products or the variables. So at this time, when we build in our objective function, at this time we need to maximize or minimize. Okay, decrease the profit or increase the profit, sorry, increase the profit or decrease or reduce the cost. So the advantage or some advantage of linear programming. Linear programming provides insights on business problems. Uh, Most of business problems we use this approach to solving some complex problem faced. It helps to solve multidimensional problems. Of course, some problems we can have a lot of variables contribute in these problems at this time. One of the approach we need to solving this kind of problem is LP. According to condition change, LP help in making the adjustment. That means the LP help us to making the right decision. So we cannot making some random decisions. We need some things. We need some approach scientific to give us this ability to making the right decisions. So by calculating the cost and profit and various things, LP help us to take the best optimal solutions. Of course, based on this LP, we can make the best or find the best solutions. Well, here I will show you an example of linear programming. Okay, so let's say Alex delivery has 6 packages to deliver in a day. That means we have this company of delivery, and this boy delivery has six packages to deliver in each day or every day in a day. You have six packages as a limit. The warehouse is located at point E. I will show you after the picture to understand more. So the warehouse is located at point E. The six delivery destinations are given by U, V, Y, X, Y, and Z. The number on the line indicates the distance between the cities. We have some lines to indicate the distance between the cities. So here what is the constraint? The constraint here is the fuel and time. So to save a fuel and time, the delivery person want to take the shortest route. Okay, here is a type of linear programming. So what is the problem? Or what is the how or what is the constraint we have here? Is fuel and time. This delivery boy should take in the shortest route to save fuel and time. And there is the picture here to understand more. So we have warehouse here in this point, and delivery boy you should per day delivery six package on all this map. So the constraint or the LP here contribute to precise for us the short route here to saving or to make on consideration this constraint we have the fuel and time. So here in this picture on this map we should chosen what is the short route here to deliver all these packages with less time and less fuel. Okay, this is a kind of linear programming. Well, here I will discuss and show you one of real linear programming problem. Okay, here I will write six. So a company manufacture to product X and Y. We have a company to factor or to product X and Y, which require the following resources. The resources are the capacities of machines M1, M2, M3. So at here, the company manufacture to product X and Y with some resources or sources. The sources is the machines M1, M2, and 3. The available capacities are 50, 25, and 50 hours. So the constraint here is the time. We have these machines and the capacity of all these machines is 50 for M1, 25 for M2, and 15 for M3. The planning period product X required. So to product or to manufacture this X product required 1 hour of machine M1 and 1 hour of machine M3. To product Y required 2 hours of machine M1 and 2 hours for machine M2 and 1 hour of machine M3. So to product or to manufacturing this product Y, we need to working in 3 machines. 2 hour machine M1, 2 hour machine M2, and 1 hour machine M3. So the profit contribution of product X and Y are 5 rupees for X and 4 rupees for Y. Okay, that's mean the price for each piece or each single product here. So for Y we have 5, and for X, sorry, for X we have 5, and for Y we have 4 respectively. Well, I will format this problem in this table to show you more. So here we have this table. We have the machines M1, M2, M3, and we have the products. We have X and Y, and we have availability in hours. So to produce X, we need just 0 hour for M1, and we need 2 hours in machine 2 with this constraint of 15. And for M2, we need 1 hour to manufacturing this X and 2 hours for Y. And for M3, we need 1 hour for X and 1 hour for Y with this constraint. And the profit here is, or yeah, the profit in rupees we have per unit, we have 5 for X and 4 for Y. So this is with other format. So here we need to maximize our function here. So the max or the functions here is 5x plus 4y. We need to max these functions and to know what is the best combination to maximize this function. So the constraint here we have for y also equal to 50. For this we have 0 for x and 2 for y. We have this constraint 50. What we have here in this constraint x plus 2y also equal to 25. Here as we see in the machine 2 we need 1 hour for x and 2 hour for y, and we have this constraint of 25. So the same times with m3 we need 1 hour for x and 1 hour for y, and we have this constraint of 50. And also for x and y should be positive or nil. Okay, I swear that's clear for you. Well, this is a simple model. So here I I use in here to solving this problem scientific package in Python. It's famous one. We have also a lot of other solvers, but for me I chose this scientific Python. So here this is the syntax. I import for some scientific Python this optimize. I import linear programming function. So here we have objective functions. Okay, as we see here we have 5 and 4. I replace it here with negative sign because linear programming in this package has not the max functions. So for this reason, we need to inverse to add in this negative sign, and then we can have the result. Okay, because to maximize this, we need to add in the minus sign. Well, this is the objective function with this coefficient of 5 and 4, minus 5 and minus 4, and we have the constraint as we see here. We have 2, this is 2, and 0 for x because we need 0 hour for x in machine 1, and we have 1 hour for x1 or 1 hour for x and 2 for y. This is here. Okay, and also we have 1 hour for m1 to produce x and 1 hour for y. So this is the constraint. And here we have the side value matrix. This value here, this is the constraint. The value is the limit of all these the capacities of the machines we have for m1, m2, m3. We replace it here. um, Sorry. So we replace it here in this vector. We have 50, 25, and 50. Well, at this time I store this in this variable optimization opt equal to linear programming. I apply my functions in this C. I passed my objective functions. Here I passed the coefficient matrix, okay, at this variable, and the third one I passed this value matrix, okay, the on the right side here. This, and I apply this method of simplex because simplex is one of the famous methods we use to solve this kind of problem. We have also other methods. Okay. Well, I run this and I get those results. Okay, so this is the result. Here in this function we have 75. 75 is the max combination or the max profit we can have with this constraint. And for the constraint, if we want to maximize our functions, we should pass 15 to product 1. That means x. Okay, to maximize our function, we need to cancel y and just product x. Okay, replace 50 here in x and cancel y. I will give it 0. Okay, I swear, I hope that's clear for you. Okay, this is the solution we have. Optimization terminates successfully. This is the best combination we can have with this constraint. So let's pass to show you another real or linear programming problem. Okay, here consider a chocolate manufacturing company that produces only two types of chocolate. This company produces two types of chocolate, type 1 or type A and type B. Both chocolates require milk and chocolate only. To manufacture each unit of A and B, following quantities are required. Okay? So each unit of A requires 1 unit of milk and 2 units of chocolate. Each unit of B, type B, requires 1 unit of milk and 2 units of chocolate. The company kitchen has total of 5 units of milk and 12 units of chocolate. On each sale, the company makes a profit of 6 rupees per unit sold A and 5 per unit B. Now, the company wishes to maximize its profit. Okay, with all these concerns we have, company wish to maximize the objective for the profit. So how many units of A and B should be produced respectively? That means to maximize our function, how much of A and B should be produced. Here, well, this with dirham. It's okay. Okay. So here in this table, I will modeling this problem. Here we have A. So to produce chocolate A, we need 1 milk, 1 unit of milk, and 3 units of chocolate. And the price for each type A of chocolate is 6 dirham. And for the previous B, we need 1 unit of milk and 2 for chocolate. And the price for unit B is 5. And the max units we have of milk in the kitchen of this company is 5, and the chocolate is 12. Okay, so now we pass to our problem here. The objective is, or the object function is minus uh, 6 and minus 5 here, because the object functions is area here, as we see. Okay, to maximize this function is z equal to 6x plus 5y. Okay, here we have the side matrix. That means coefficient of our. This is we have 5 and 12 here, we see. Okay, and we have the constraint it's 1 unit of milk and 3 units of chocolate. And for B we have 1 unit for B and 2 for chocolate. Okay, so we apply this linear programming here. We have passed our fraction object. This is the constraints here is 5 and 12, and the last one, the right side matrix methods here, we have 5 and 12 here, and we apply also this simplex method. So when I run this piece of code, I get this result now. So the function, the maximization function is 13. Okay, we drop this minus c, because as I said before, to maximize we need to add in, we need to add in this minus c. But in solution we drop it. Here the max value here is 30. That means to the max profit we can have with all these constraints is 30. And we should just produce 5 type A and 0 type B. To get this profit, we should just produce 5 type A and 0 for B. Okay, I hope that's clear for you. So also we have another package I found it just randomly. It's called PILP in Python. It's work can program and maximize. We need to maximize our combination. We create also two variables. We have x. We create this variable as lower bound equal to 0. That means x should be positive or equal to 0. The same thing with y. Y is a p variable. Lower bound is equal to 0. That means this variable is greater or equal to 0. And objective functions here is 6, or yeah, 6 times x, or 6x plus 5y. This is our function here. I don't write it here with this sign Python. Okay, well, here it's clear maybe. So this is our objective function. The constraint is we need 1 unit for for producing the type A, and 2 units for producing type B, and the max is 6 units. We have just 6 units. Okay, so as we see here, right? So this constraint here, 5, sorry, so we need to replace, so this is constraint 5 here for milk and 12 for sugar. So how much of 3, here we have 5 and we have 12 here. X, y, sorry, checking again, because it's the first time I work with this package. So for the reason I need to check in. Okay, let me check in again. Here we go. This is constraint of triple profit per unit. If I run it, make it some result. Yeah, that's correct. So here, this is the objective function, 6x plus yy, and we have the first constraint. We need what unit of type of milk, and 2 units for chocolate, and we have the limit. Okay, the limit here is 5. Okay, and we have also we need here we need one one unit of milk and 2 units of chocolate. Okay, if I run it again. Okay, so here we have this second constraint. We have 1 unit of milk and 2 units of chocolate, and this is the limit. That's all we have in the kitchen of company. 5 units of milk and 12 of chocolate. Then here we apply this solver. Okay, such you when you program the solver here, and we call also the status and the current values of y and x, the objective function here. So when I run it, I get this result. We need to maximize this function, 6x plus 5y, and this is the constraint. Okay, constraint. Well, the optimal function or the optimal combination, that is we need also, sorry, 5 unit of type E and 0 for type B, because we have two type of chocolate as we see here. I will return to show you. Okay, so to create type A, we need 1 unit of milk and 2 unit of chocolate. B, we need 1 unit for milk and two unit of chocolate. And this is the constraint. We have just 5 units in milk and 20 of chocolate. So the best combination to maximize our profit is to create just 5 of type A. We cancel type B. We just produce type A. Okay. So I get the same result here. See what they get. 13 as the max combination or the max profit we can get when we create 5 type A. Well, I will show you maybe the last real problem. Suppose a manufacturer of printed circuit has a stock of 200 resistors, 120 transistors, and 150 capacitor, and is required to produce two type of circuit. We need or to create this type of circuit, type A and type B. We need, so first it's starting from with type A required 20 resistor and 10 transistors and 10 capacitor. For type B required 10 resistor, 20 transistor and 30 capacitor. If the profit of type A is 20 dirhams and that on type B is 90 dirhams, how many of each circuit should be produced in order to maximize the profit? That means how much of type B I should produce and how much of type E I would create to maximize my cost or my profit function. So this is the problem here. This is the constraint. We need to maximize this function 20x plus 90y. We have here, this is constraint, x is type E and y type B. Okay, just this note, we have this constraint now. We have 20x plus 10y is less or equal to 200. 10x plus 20y is less or equal to 120, and 10x plus 13y is less or equal to 150. And of course, x and y should be equal, so should be equal, should be positive or equal to 0. So, well, I work here with y. This is my object function 20 and 90. As we see here is the object or this cost or this profit function. We have the constant y of x. This is constant 20 and 10 here, and we have also 10 and 20 here, and 10 and 30 here. Okay, this is the constant or the coefficient of constant. Here I'm writing the limit we have. We have just in our stock 200 resistor and 120 transistor and 150 capacitor. Okay, well, I apply again this function of linear programming. I pass my object function here and constraint of x and y, and here I pass the side right of my problem. Here I use again the simplex method. So when I run it, so this is the result I get 550. This is the max combination or the max profit I can found if I produce just 5 type of B, just 5 circuit B, type B. I cancel A and they work just with B to maximize my profit function. So I hope that is clear for you all. Happy learning for everyone again, and see you again